Hi everybody. Decisions, decisions, decisions. We're going to look at decisions in Python. The first decision statement is if. Without these decision statements, our program would go from the beginning to the end exactly the same way every time. Well, if is a comparison statement. This is a relational operator. So let's start with the one we use most commonly, which is the equals to. It's not really equals to, it's comparing. Is the value in the x variable the same as 0? Well, we can see that it's not. So this expression will return false, which means this code will never be executed. How do I know this code belongs with this? The indent. If I indent it over, it goes with that code. If I type something here, it does not belong to the decision statement. This will always run. So just say bye. Let's see how that works. So start. It said bye. Why did it say bye? Well, because x was not equal to 0, which means that was false. So the program jumps on by. We can also do other statements, like we can decide, is x greater than 0? Well, let's see what happens. Let's see if 1 is greater than 0. And it is. X is positive. So that's greater than. We also have less than. Is x less than 0? Well, you know the answer to this already. It's not. It's not less than 0. Those are three of the ones that we're going to use a lot. We will also use less than or equal to. So is 1 less than or equal to 0? No, I don't think so. And the computer confirmed it. It is not. What if we do this? Greater than or equal to 0. Is that going to come up positive? Well, it sure does. All right, so we've gone through some of the basic relational statements. Now the next piece that we want to look at is when we're making a decision, this expression evaluates as either true or false. There's no in between. And I don't have an if-else, so I'll just add one in here. Oh, odd and even. There it is. Let's use odd and even. Odd and even. This program uses the modulo operator. It returns the remainder of integer division. So if whatever number I enter, say it's a 2, I divide 2 by 2, there is no remainder. So it's 0, which makes it even. If I divide 3 by 2, I end up with 1 left over, which means that 3 is odd. If 4 is divided by 2, the remainder is 0. Because 4 is divided by 2, it comes out. 5 divided by 2, well, it's 1. 6 divided by 2, it's 0. So you can see where this is going. It's either 0 or 1. Well, let's find out if this works. If I type in 1, well, 1 is odd. If I type in 2, 2 is even. So I can keep running this all day and go up to 1,000,000 digits, and it's always going to give me the answer. So if I type in 2, 2, 2, 2, 2, 2, 2, uh-oh, didn't type in. Still numlock. There we go. That's odd. So either it is even or it is odd. Now else is optional. You'd put else in there if you want something else to happen. If this is not true, if this returns false, then this is going to happen. Well, quite often we have multiple things that we want to determine. Are they true or false? And this grades is a good example. There we go. There's grades. So we get a score from the user. And that's the wrong one. I want grades. There it is, grades LF. Got the wrong one. There, that's the right one. So LF is what we use when we have to make multiple decisions. There's only one right answer, but we can make multiple decisions. Well, that's not the right thing to say. So just say I type in 95. Well, 95 is greater than or equal to 90. I print A and I exit. I'm done. If I have 75, well, 75 is not greater than 80. It's not greater than 90. No, it's not greater than 80. It's not greater than, it's not greater than 90. It's not greater than 80. It's greater than 70. So I would print a C. What if I have a 45? Not greater, not greater, not greater, not greater. The only other option is if it's not greater than 60, it's 49 or 59 and below. So that goes over here. Else means if all those other decisions turn false, it'll go to the else. Whichever decision turns true first is where we go, we print, and then we exit. My score is 95. Yep, I get an A. Right? Because it get caught here. So you're eliminating choices. So if I do 80, oops, I'm typing in my code. If I do 80, that's a B. Don't want to type in my code, that'll wreck it. So you can think of decision statements as elimination. Once we've tested for equal to, greater than or equal to 90, we never have to test that again. All we have to do is test 89 and below, because that's all that's left. We've eliminated everything from here on up. When we test for 80, we never have to test for above 80 again because we've eliminated it. It isn't in that range. And so eventually, by eliminating everything, we end up with, well, if it's not greater than 60, then the only other option is it has to be 60 and below. That's it. We've eliminated everything. So think of decision statements as elimination. Here's a simple little game that I added in here to introduce a new concept, which is random numbers. Without random numbers, the computer does the same thing every time. Random numbers are used a lot in gaming because you don't always want the same thing to happen every time. We'll use it in this simple game. When we're importing something from someone else's code into this program. Python has what's called a standard library, which contains a lot of things, but they don't want everything that could possibly be in Python, or you'd never be able to download and install it. So there's a random library. A library is code that somebody else typed in and you can use. From that random library, we're going to import the randint function that generates a random number between, in this case, I put 1 and 10. If I put 1 and 20, it would be 1 and 20. So this is the min, this is the max. Once this has generated a random number, it's stored in this variable. Well, let's make sure that it is random. Let's print out the random number. Yep, there it is. Sorry. Well, this time it's 4. This time it's 5. 7. And sometimes it'll come up with the same number twice in a row. Yep, so far it's been different numbers. Well, we don't need to print that out. I was doing that just to show that we get random numbers. The computer generates a random number, 1 to 10, inclusive, which means it includes 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We type in a guess between 1 and 10. If our guess is the same as the random number, it's true. If our guess is not the same as the random number, we lose. Well, you only get one chance because this doesn't have a loop. We'll loop this later on. So if I do 5, oh, didn't work. It was 7. Let's try that again. We'll try 5 again. Well, eventually it's going to get 5, but also notice that it did 7 twice in a row. The odds of hitting any number are exactly the same each time you run it. So there's our simple little game. We'll work on making that a little more fun later on with loops so we can try it again and again. Logical operators. Oh, I don't know where that 22 came from. It's not supposed to be in there. All right, the first thing we do is type in our age. If our age is greater than 16 and our age is less than 65, we're going to have a good day at work because that's the normal working age, 70 to 60, 16 through 65, or at least I'm pretending that for this program. If my age is 69, it says enjoy your free time. This program is assuming if I'm over 65, I'm retired and I just do whatever I want, or I'm under 16 and I don't have to work. So both of these have to be true before this is true. Or, which this is just like in math, if I'm less than 16 or over 65, I enjoy my free time. Otherwise, I have a good day at work. So notice how they're backwards because we're testing in opposite directions. So if I put in 15, I don't have to test any further. If my age is less than 15, I enjoy my free time. If my age is greater than 65, I can enjoy my free time. The only time it goes down here is if it's in between. So either of them can be true. Both of them have to be true. We won't use these very often. In fact, usually there's a better way to do it. Oh, there we go. And if I'm 33, I have to work. And if I'm 69, oops, I typed in my program again. There, I enjoy my free time. Well, that is the gist or the basics of decisions. We will be working with decisions for the rest of our time with Python. We never get away from them.